Let's have a look at question 15 over here. So we assume that the cost of effort is 55, the probability of being caught shirking it's a half, and the salary for an old employee is 120. So the wage of an old employee is equal to 120, cost 55, probability 1/2. Now if the salary for young employees is higher than 45, then both young and old employees choose to work hard. So first of all, let's see what happens for a young employee. When does a young worker decide to work instead of shirking? So the utility, let me just change colors here, the utility of a young worker of working must be greater than the utility of a young worker of shirking, right? But because he is young, we have to keep in mind that he thinks about his future as well. He thinks about what he's doing in the moment, and he also has to think about what's going to happen next when he is old, because this is the first period, but he has to live one more period. So for the young worker, we'll keep in mind that he has a future period to live as well. In other words, if he works, he decides to work in both periods. So he'll have the wage of a young worker minus the cost of a young worker, plus he'll have a wage when he is old minus the cost when he is old, right? Under this scenario, he just decides to work. Now, over here, we'll keep in mind that he will be shirking when he is young. He will be shirking when he is young. Now, what's that going to be? Well, there is a probability P that he will be caught. So there is a probability P that he will be caught shirking when he is young. And in that case, he just gets 0. He has no money and no cost. Now, with the remaining probability, let me just write it over here like that. This is being caught shirking, right? So he is caught shirking. Now, but the remaining probability 1 minus P, with the remaining probability 1 minus P, what do we have over here? We will have the following. We will have the wage of the young employee minus 0 cost, because he would be shirking when he is young. The condition is that he is shirking only when he is young. So he still gets his salary, he gets away with it, but he pays no cost for it. But in the second period, he would get the wage of an old employee minus the cost of an old employee, because in the second period he would be working. The condition here is just he's shirking when he is young. Hope this makes sense. So let's just write a bit of a highlight below this to understand what's happening here. So shirk when young, work when old, Now, let's substitute some data, because we have data that we can use over here. We have the cost of effort, we have the wage of an old employee, and so on. So we will have the wage of a young employee minus the cost of effort, which is 55 given in the question, 55, plus the wage of an old worker, which is given as 120, so plus 120, minus the cost, which is again 55, is greater than, this one becomes 0, so we're leaving it like that, and we're left with 1 minus the probability, which is 1 minus a half, right? The probability is also given to us from here, it's a half, so 1 minus a half, multiplied with, and what do we have in these brackets? Wage of a young worker, plus wage of an old worker, which is again 120, minus the cost of an old worker, which is also 55. Now let's solve the math over here to see what we get. We'll get the following. We'll have the wage of a young employee minus 55 is minus 110, plus 120 becomes plus 10, is greater than a half multiplied with the wage of a young employee plus 120 minus 55, this is just 65, so plus 65. Now let's open the brackets here to see what we get. What do we get? We'll have wage of a young employee plus 10 is greater than a half times the wage of a young employee, so that, plus 65 divided by 2, which is equal to 32.5. Now let's take the wages on one side, the numbers on the other side, to see the relationship between the two. So we take this one over there, and we will have wage of a young employee minus a half of the wage. It's 1/2 wage of the young employee is greater than, we take 10 to the other side, so 32.5 minus 10 is 22.5. Now if we divide this one by a half, so we take a half to the other side, we will have that the wage of a young employee must be greater than 22.5 divided by half is the same as 22.5 multiplying by 2, so that's equal to 45. So if the wage of a young employee is greater than 45, then the worker will work. The young worker will choose to work, okay? Now let's solve it for the case when he is old. When he is old, we found the relationship in the previous video that this has to hold true. So let's just crop this over here below. This relationship must hold true. Let's copy and paste it over here. Now we know that the wage of an old employee is 120. So 120 must be greater than, let's see if that's gonna be true, must be greater than the cost. The cost is given in the question as 55, right? It's given in the question as 55, and the P is gonna be a half. If the P is gonna be a half, so 120 must be greater than 55 divided by 2, which is equal to 120 greater than 110. So that holds true. If this holds true, then indeed the worker will work hard when he is old. So this is true. This is true. He will work hard when he is old, and when he is young, he must have a salary greater than 45. And if we look at the answer key, what do we have over here? What do we have over here? If the salary for young employees is higher than 45, then both old employees and young employees choose to work hard. And yes, that is true, and we are done.